Hello, my dear students. Welcome back to my class in the series of learning programming in C. In the previous video, we have discussed about structure padding. Well, in today's video, we will discuss about structure packing. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Structure packing. In the previous video, we discussed about structure padding. So it is the process wherein which the compiler is going to insert additional padding bytes so that it can reach or it can match the memory architecture. So it depends upon the architecture of the machine. Say for example, if I just say it is 32-bit machine, one word access means 4 bytes of data. So the data has to be aligned properly so that in one cycle it can fetch one complete set of data, that is one word of data, that is 4 bytes. So the members that what we have in the structure has to be aligned properly in the memory so that the CPU, the processor, can access the data properly. So if I just say in one cycle, it is accessing the data means one word of data. With respect to 32-bit machine means 4 bytes of data will be fetched at one stretch. So we have discussed about these things in the previous video. Please do check out the playlist. First, you need to understand what is structure padding. Then you can understand what is structure packing. Right. So the processor must be able to access your data that what we have stored in the memory easily. But when I say the padding bytes increases, the memory utilization also increases. The efficiency of the memory decreases. So when more bytes of memory is utilized, that is not good to our program. So we have to pack that memory. In some machines, this packing will be done automatically, but we need to do this by adding additional directive. So let us understand what actually this structure packing is. What is the additional directives that we need to include so that the bytes gets packed and the memory utilization becomes effective. So let us understand what is structure packing now. So, structured packing refers to the way the compiler arranges the members of the structure in memory. The members of the structure has to be arranged properly inside the memory, and that is what structured packing. When structure is defined, the compiler decides how to lay out the structure members. So as soon as we do the structure definition, the compiler decides how to have the memory allocation for the structure members, including the padding bytes, if any, to ensure proper data alignment. So data alignment is the most important thing that what the compiler has to do. The compiler will do this automatically. So as soon as we define the structure, the members has to be aligned properly. And it is the responsibility of the programmer also to have the data members declared in the increasing order of their storage allocation. So when we have the increasing order of the storage allocation means the padding bytes will also be reduced. These things we have discussed in the previous video. Well, alignment and packing of members can impact the memory usage and the performance of the program. So if the alignment, the data is aligned properly in the memory and if it is packed properly, then I can say the memory usage and the performance of the program is proper. So I have to use the memory, I have to increase the performance of the program. By default, most compiler add padding bytes to align the structure members. By default itself, the compiler will do this task. It is going to add the padding bytes so that it can align the structure members and ensure that the data access is efficient and aligned. And how many bytes, padding bytes has to be added, that is dependent on the machine. So it is machine dependent. So if, as I said in the previous video, we discussed about the padding of the structure. See, if it is a 32-bit machine, then I say it is one word equal to 4 bytes. So in one cycle, the CPU can fetch one word of data, means it can fetch 4 bytes of data. Say if it is 32-bit machine, it is one word, in the sense 4 bytes of data fetched in one cycle. Right. So that is machine dependent, and based on this, the compiler decides how many padding bytes has to be filled. So it will be done by default and it will be taken care by the compiler itself. And in some cases, what happens, the packing of memory is required to optimize the memory usage. But sometimes if the padding bytes increases, then we are not using the memory effectively. So in such cases, we have to pack the memory so that the memory can be effectively utilized. And this is done using the compiler specific directives like ash pragma pack of n represents n bytes boundaries. Say if I just say pack of 1, so I just say ash pragma. So for example, ash pragma, I say pack of 1 means 1 byte boundaries it is going to set member to member. So this packing of memory is very much essential so that I can align the data in the memory and use the memory effectively and increase the performance of the program. So how to add this pragma, how the memory can be packed? Let us see with examples. So let us understand the structure packing with this simple example. So we have a structure by name test, and we have the members character A, integer B and character C, and structure variable yes. So in the main function, what we'll do, we'll try to print the size of the structure with the help of size of yes. So what will be the output for this? Let us analyze now. So here what happens, character A means it should get only 1 byte, right? So here according to the data alignment, compiler is going to fill the padding bytes. It is just 1 byte, so A is only 1 byte. The remaining 3 bytes will be the padding bytes, right? Then integer, it requires 4 bytes with respect to 32-bit machine. Then again it is character C, which is just 1 byte. Again the remaining 3 bytes will be the padding bytes. So totally it is 4 plus 4 plus 4. The size of yes will be 12 bytes. See, simply the memory is getting wasted because the machines, the CPU has to fetch one word. If I talk about the 32-bit machine, one word equal to 4 bytes. So this 4 bytes of data is fetched in one cycle. So the data is aligned in such a way that when the CPU can fetch one cycle, it is going to fetch 4 bytes of data, that is one word. So this 4 bytes of data, in the sense, here character requires 1 byte. The remaining 3 bytes will be filled, will be padded automatically by the compiler. So the memory is getting wasted here. So 3 bytes are waste here. Integer, it is 4 bytes. So for one word, the complete 4 bytes will be fetched. See, if it is byte accessible, means for every cycle, it will fetch only one byte. But nowadays it is not byte addressable, it is word addressable. So it is saying one word I am fetching, in the sense I am fetching 4 bytes in one cycle at a stretch. So 4 bytes for integer, then character it is 1 byte, but it has to align the data. The compiler will do the alignment of data so that it can access the data very easily. So when I say one word, means it will fetch the complete one word with 4 bytes, where only 1 byte of data will be there, and the remaining 3 bytes, again here we have the padding bytes. So we have the padding bytes here. So this is padding bytes. So totally 12 bytes it is going to show. Right? Now, if the programmer arranges the data in the increasing order, so what I'll do now, I'll simply say character A, character C, then integer B. Okay. So A, it takes 1 byte. So for character, it will take the memory in any way. So 1 byte. Then what happens? We have B. It is C. So we have character A and character C. So it is C which takes 1 byte, A which takes 1 byte. A 1 byte, C 1 byte. The remaining 2 bytes are padding bytes. So totally it is 4 bytes. One word is done. Then integer 4 bytes. So this memory will not be there. Right? So here what happens? The first, so I am arranging the members in increasing order of the memory allocation. Characters can be allocated in any way. So the first character A takes 1 byte, second character C takes 1 byte. So the remaining 2 bytes will be filled as padding bytes by the compiler. So totally 4 bytes. Okay. So it is 1 plus 1 plus excuse me, 4. So actually saying it is 5 bytes. But what happens here? So it is 4 bytes for integer, 1 byte for character, 1 byte for one more character. So it is 4, 5, 6. Totally 6 bytes will be the actual storage. But the compiler is going to fill padding bytes. Here A takes 1 byte, C takes 1 byte, and remaining 2 bytes will be padding bytes. So here totally it consumes 4 plus 4 for integer. So what happens? It is 8. So here what will be the bytes? It is 8 bytes. So it is 8 bytes. If I arrange it in increasing order, so I can do this management. The programmer should know this to align or to create the members in the increasing order so that less amount of padding bytes will be filled. But sometimes all these cases or arranging the members in the proper order sometimes cannot be managed by the programmer. So what we can do, we can have a directive called as ash pragma, I say pack of 1. I say ash pragma pack of 1. Then the compiler is going to pack the bytes. So these 2 additional bytes that what the compiler filled will not be done. So it will take 1 byte for A, 1 byte for C, then these padding bytes will not be created. It is going to pack the data. Then what happens? The next 4 bytes. The next 4 bytes, that is 1, 2, 3, 4. So A, C, then it is B. 1, 2, 3, 4. So it is 1 plus 1 plus 4. So what will be the size? 4. So it is 1, 2, 3, 4. 4 plus 1 plus 1. It is 6 bytes for the structure. Yes, when we do this or when we include this directive pragma, it is going to pack the padding bytes. So no additional padding bytes will be included. So this is how we can do the packing of structure. If I fail to arrange in increasing order also, say I'll just say character A, then I'll say integer B, then I say character C. Character A, 1 byte, then I say integer, then it is 4 bytes, 1, 2, 3, 4. So this is for B. Then it is for C, 1 byte. So it is like this. Character 1 byte, 1, 2, 3, 4. Integer 4 bytes. Then again character 1 byte. So it is 1 plus 4 plus 1. It is again 6 bytes. So if the programmer fails to arrange the members in increasing order also, this pragma will help to pack the data. So if I just try to print the size of the structure, it is again going to print 6 bytes only. It is 1 plus 4 plus 1. 1, 4 and 1. 6 bytes. So this is what structure packing. So what happens, the compiler will do the packing of the members so that it can be aligned properly and the memory can be utilized effectively. So this is what structure packing. Let us understand this with the program practically also. So here we have the program to understand structure packing. So here the structure by name test has the members A of character type, B of integer type, and then we have C of character type. So when I say what is the size of the structure, yes, so we can just say without the structure packing. If I say it is structure padding which is done by the compiler. So here for character the memory allocation will be for character it is totally 1 byte, but with structure padding the compiler inserts padding bytes, so it is 4 bytes, then integer 4 bytes, then character C actually it is 1 byte but padding bytes will be inserted by the compiler automatically, so extra 3 bytes, so it is 4 plus 4 plus 4. So I am going to get the size of the structure yes as 12 bytes. So let us see this now. To save this program, run the program, see here. So the size of the structure so here we go with the program to understand structure packing. So the structure name is test and we have the members A, B, C of character, integer and character data type respectively. Then we have a structure variable yes, and in the main function we are trying to print the size of the structure with the help of size of. So actual saying we know that the storage capacity for character it is 1 byte, say integer with respect to 32-bit machine it is 4 bytes, then it is C 1 byte. So it is 1 plus 4 plus 1. So we just say that it is going to print 6 bytes, but no. But what happens here? The compiler is going to insert the extra padding bytes. So character, I say it is 1. So if it is with respect to 32-bit machine, one cycle means one word equal to 4 bytes. So character 1 byte plus 3 bytes padding bytes. Then integer 4 bytes. Character 1 byte plus 3 bytes. So here character it is actually 1 byte, but 3 bytes will be padding byte which is filled by the compiler. Then 4, then we say character C, it is 1 byte followed with the extra 3 bytes padding byte, so it is totally 4 plus 4 plus 4, 12 bytes. Actual size of the structure will be 12 bytes. Now if I just ask the compiler to print the size of yes, it is going to print 12. So let us see that now. Save the program, run the program. See, size of the structure it is going to print 12. But what as a programmer we can do? We can just rearrange these data members in an increasing order. So what I'll do, I'll just say character C. So all these things I am doing without structure packing. So what happens here? If I just say character A, character C, then integer. So as a programmer, we should know how to arrange the members in increasing order so that we can efficiently use the memory. So here what happens? Character can be allocated somehow. So it is 1 byte, so it is 2 bytes. Plus 2 extra bytes as padding bytes. So compiler is going to fill 2 extra bytes as padding bytes. So it is 4 plus 4. So it is going to print 6. So somehow the padding bytes is minimized. Right. So when I arrange the members, so like this, the alignment of the data will be done and the compiler is going to fill the padding bytes. So now I can say it is going to allocate how many bytes? Run the program now. See, I can get. So it is totally for character 1 byte plus 2. Totally 2 bytes extra. So it is 4 plus 4. So it is 8 bytes. So somehow without structure packing, I managed this. But how I can pack these memory? How I can efficiently use the memory? So for that, I need to include pragma, or I can just say hash pragma pack of 1. Now what happens? The structure packing will be done, so additional padding bytes will not be filled. So what will be the size now? It is 1 plus 1 plus 4. So it is 6 bytes. Just save the program and run the program. See, what will be my answer? C. The size of the structure is 6. So this is how I can use this structure packing. I can pack the memory and efficiently use the memory. So it is 1 byte for character, 1 byte for one more character. For A it is 1 byte, C it is 1 byte, then for B it is 4 bytes. So 4 plus 5, 1 plus 1, it is 6 bytes. So structure packing is done here. So what I'll do now, character A, integer B, then I'll say character C. So look at here, even though if I change the order here, so I just say character A, integer B, as a programmer, I need to have the arrange the data members in an increasing order, but sometimes if I fail to do this, so I'll just say it is character A, integer B and character C. So actual saying, if I don't have structure packing, so my storage will be, it is totally 4 plus 4 plus 4. But now I have structure packing. So the memory will be packed. So extra padding bytes will not be inserted. So what will be my output? Just save this and execute. See, even though the programmer fails to do the arrangement of data members in increasing order, the memory will be 6 itself, because I have this pragma pack of 1, that is structure packing. This is going to take care of packing the memory bytes. So extra padding bytes will not be inserted. So, and see, now let me arrange this. So I'll just say character C, then I'll say character integer B. So now I have arranged it. Again you get the same storage itself. Just run the program. So let me clear the screen here. See, now run the file. See, I'm going to get 6. So hope you have understood with the structure, padding and packing. That's all for today's video. So in the next video, till then, take care. Bye bye.